This is the review for the corn test. So we're going to start. First one I have is looking at how long did it take you to apply it, and what was how much did it cost to plant? And so let's look at how many days did it take it to apply the herbicide when working a 14-hour day. So first off, we need to figure out how big the field is. We're told it's 750 acres, but that we need to work with it in feet because the conversion rate you want to be able to work with is going to work better in feet, because we don't want to convert our 60-foot sprayer into a mile or an acre. And so we need it all in feet. So 750 times, there are 43,560 feet in an acre, or square feet in an acre, which when you multiply that gives us 32,670,000 feet, square feet. Now, what we're going to try to do is we're going to picture out, if I was to make this into one long strip of just with my 30-foot sprayer, and this is that 32 for the area, what would the length be? So we're going to take that 32 million number and we're going to divide it by how big our sprayer is. And that gives us the fact that there is 1,089,000 square feet. Now we're going to talk about this. Now we are done with that part. We've already got it figured out for that strip. And so now we're going to take and convert this into mileage so we have something to work with. So we're going to divide it by how many feet are in a mile, which is 5,280. And that gives us our mileage, which is 206 miles and 25 hundredths. So we now know how long it is. Next is we're going to try to figure out, we're going to take that 206, and we need to figure out how many hours that would take. So we're going to divide it by our speed, which our speed is 4.5 miles per hour. And when we divide those two numbers, you end up with approximately 46 hours. Well, we're going to assume that you're not working a 24-hour day, that you actually do go to bed at night. And so we are going to, it said that we are working 14-hour days. So I'm going to divide this by, actually before I do that, let's go ahead and get it, how many hours we're actually going to be working, because what we didn't count into effect is the fact that our field is not just a straight field. We need to take it an extra 15% of the total time for turning and filling. And so that means we're going to add in 46 times 15%. And that will give us our number of hours as roughly 52 and a half. So now we're going to take that 52 and a half and divide it by the fact that we're working 14-hour days. And so when we take that 52.5 divided by 14, we come up with 3.75 or 3 3/4 of a day. Is how much you're going to need to work. So we could increase that time by getting a bigger sprayer or by going faster than 4.5 miles per hour. Make sure our equipment is able to travel faster. Make sure that the weather conditions are correct. And gain a bigger sprayer. So what is the cost of the herbicide? We can't buy a partial container, so we need to figure out, okay, I have 750 acres. Each acre is going to have 2 pints. And so that means that I am going to use 1,500 pints. But we need it to get into container amounts. Each container is 2.5 gallons. So first step is to go to gallons. So to convert it to gallons, I need to divide it by 8. So when I divide it by 8, I get 187.5 gallons. Well, each container isn't just 1 gallon, it's 2.5 gallons. So I'm going to take that 187.5 and divide it by my 2.5 gallons. And that tells us that I am going to get 75 containers. This one didn't need to round, but remember that you can't have a partial gallon. So we would make sure that we have converted it to the right thing. And so each container was $85.20. So when I multiply those, I come up with that it's going to cost me $6,390. So the seed corn, same idea. We're planting 30,000 kernels per acre. We have 750 acres. And so we're going to be dealing with large numbers here. And so when we multiply those two together, we come up with 22,500,000. Each bag of corn is going to hold 80 kernels. So I'm going to take how many kernels and divide it by how much is in one bag. When I divide those two numbers, I come up with 2.81.25. You can't buy a 0.25 of a bag. If I don't buy that quarter, I'm not going to have enough kernels to cover my entire field. So I need to round up. And so that's going to be approximately 282 bags that you need to purchase. Well, that 282 bags, they each cost $250, which means we have 70,500 that we have spent there. So now, not every kernel is going to pop up to plant. And if you estimate how many are out there, you see that you have 27,900 roughly in your population. So what is your germination rate? What percent came up? So 27,900 came up out of your 30,000 kernels planted, which gives you a 93% germination. Remember to take and move that decimal over by 2 or multiply by 100. Next thing we're going to go on to is we're going to be working with how do you fertilize your land. So when you're fertilizing your land, you need to consider each of the different things that are going into your fertilizer. And so we want 210, 45, 30. Remember, this first number deals with our nitrogen content. The second number deals with our phosphorus content. And this last number deals with our muriate of potash, which is going to contain our oxidized potassium. So those are the three chemicals we are trying to work with to create what we need. So each of the numbers have a different amount. And so we know we're told some information up here. And this information we're told up here helps us start. So it tells us we need 6 gallons per acre of rose starter. Well, it tells me my rose starter is 11.78 pounds per acre. So I'm going to take the 6 gallons and multiply it by 11.78. And that gives you 70.68 pounds per acre. Well, we're not going to just plant 1 acre. We're actually going to plant all our acres. So we're going to take that number and multiply it times the 750 acres that we are planting. And that gives us 53,010. And that's how many pounds of rose starter we needed, or we used. Now, let's go on to the next thing. How many pounds of anhydrous ammonia were needed? So that's going to be giving us part of our nitrogen content that we needed. We need 82%. It's going to give us 82% nitrogen. And so that means that we are going to be needing to take and find out the other components we need. We've already got the rose starter. We know that we had, for our rose starter, we had 70.68. Now, not all of that 70 goes to each of these components. We're going to have 2 different components that come into play. And so we're going to go ahead and kind of skip and go to, oops. Look at DAP first. The reason we're going to do this is it helps us find one of the other components, because if you look, you'll see that for nitrogen, these 3 are involved. But if I look at my phosphorus we have these two involved. And so I'm trying to narrow it down to where I'm only taking and using a little bit at a time. And you could have gone on to the muriate of potash to help you find your potassium that was being added in. But we're going to start here at the DAP. So of that 70,000, out of that 70.68, 34% is the chemical we're looking for, P2O5. And so we're going to take that 70.68 and we're going to times it by the 34 hundredths. And that gives us the fact that there were 24 pounds of our potassium oxide, out of our oxidized phosphorus. And so we have 24 pounds here. We need to get to 45 pounds. So that means that we need to subtract those two. And so we need 45 minus 24, which is going to give us 21 pounds. So that 21 pounds that we need to get it from somewhere else. Well, DAP has it. And so we're going to take that 21 pounds that we need and divide it by the DAP amount for our oxidized phosphorus, which is 46% of that amount. So when I take that 21 and I divide it by that 0.46, I end up with 46 pounds of DAP. But that's how much we're needing per acre. So we need to take that 46 and multiply it times by 750 acres. And I get 34,500. Now we're going to go back to our ammonia. We know that we had wrong way. That we had 46 pounds of DAP. So 46 pounds of our DAP. And so out of that 46 pounds, it's 46%. So I'm going to multiply it by 46%. Was you 21.16. So between that and our row starter, which was 70.68 times that 34, which is 24.02. We get a total of 4518. So we have at 46 pounds of DAP, we have 70.68 pounds of row starter. We're trying to figure out how much ammonium we need. And so out of that row starter, 70.68, 10% is that going to be the urea, or not urea, but the nitrogen. And so that gives us 7.07, just for rounding purposes. But at our DAP, we had that 46 pounds at 18%. So if we do 46 times 18, you come up with 8.28. And then we add those two together, and we end up with 15.35. And that's how much nitrogen we have already generated between our two other products we've already calculated. Now we need to take and figure out how much more we need. And so we're going to find out how much more we need. We take our 210 and subtract from it the 15.35. 35. And that gives you the 194.65. So we need 194 pounds of we have out of our, we need 194.65 pounds of nitrogen. So where we're going to look for that is in our ammonia. And so the anhydrous ammonia has 82%. So to figure out how many pounds of that we need, we take the 194.65 and divide it by 0.82, which gives us 237.38 pounds per acre. But we have 750 acres, so we're going to multiply that times 750, and we end up with 178,033.5. So I'm going to go ahead and round that to 178.34. And so we're going to be taking and finding the muriate of potash that we need, which is what's going to give us our oxidized potassium, which is 60% of that level. And so we need 30 pounds of oxidized potassium. What we're getting it from is going to give us 60%. So we're going to divide it by 0.6. So you take 30 divided by 0.6, you end up with 50. So we need 50 pounds per acre. So now we have 750 acres, times my 50 pounds. And that gives you 37,500. Oh, not dollars. Pounds that we need. Now, most of these are usually sold by the ton. As you look at our prices, they're priced by the ton. And so you can either take and adjust your price to be not by the ton, but by the pound. Or you can take and adjust your weight to be into tons when you start calculating the cost. And so the cost of the fertilizer we need to take each of those costs that or each of those dollar amounts that we found. So like that, we know we needed 37,500 here. We needed 178.34 here. I can't, and we needed 34,500 of our DAP. And we needed on our row starter 778.34. Oh, wait a minute, no, that's not the row starter. There's the row starter. We needed 53.10 of our row starter. And so when we're going to try to find out the total cost, we're going to have to find each of their costs and add it together. So we're going to take the amount we need times the cost divided by 2,000, because it's 2,000 pounds in a ton. So when we multiply that out, which gives us this one's going to cost us 56,080.71. We're going to go on to the DAP the same way, so 34,500. And we're going to multiply it by that 499 divided by 2,000 and see what we come up with. So 34,500 times 499 divided by 2,000. Gives you $8,607.75. Then our muriate of potash, we're going to do the same idea. We're going to take the 37,500, multiply it by 520 divided by 2,000, and we come up with 9,750. And the last one is our row starter, which we needed 53,010 pounds. We'll multiply it times that 420 divided by 2,000. And so you should have come up with 111. Excuse me, $132.10. Now you're going to add all those together, and that becomes your cost, which gives you a total of $85,570.56. Now, if we take it the next step, we want to figure out how much does it cost per acre. We're going to take that same $85,570
Teacher, pardon the interruption.
And so you take that 0.56 and you're going to divide it by how many acres you have, which is 750, which will tell you that your cost per acre is $114.09. So in the next bit, your harvesting capacity is used by calculating different aspects. So you're going to take your speed, your width, and make sure that you do this correctly because this is not in inches, but this is in feet. So often we're going to be told our row width, and then we have to take and multiply it times our how many row unit we have, and divide it by feet, which is 12. Your efficiency and your yield. And so our speed was 4.6. Our efficiency was 85 hundredths. Our yield, it told us our yield was 150 bushels per acre. And so all we got to do is find our feet of our plow. So that is 12 inches, or 12 rows times 30 inches divided by 12, which is 30 feet. And so our width is 30 feet. And so all you're going to do is you're going to take those numbers, 4.6 times 30 times 85 hundredths times 150 and then divide all of that by 8.25. And so that means you're going to divide 17,595 by that 8.25 number. And that would give you your number of $21. $33. Because it's technically 32.7, but that 7 tells a 3 to round up. Next, it's going to get into the more complicated. We're going to start looking at our grainage, our bins. And so we have the top cone and the bottom storage bin that's a cylinder. We know that our diameter is 38 feet, and then it's 20 feet to the roof and another 8 feet above that to get to the top of the roof, and we can only do 82% capacity in that top portion. So to find the volume of the cone, we take our radius and we're going to square it times pi divided by times our height divided by 3. And then we really are going to have to take and multiply that number by 0.82 because we can only use 82% of the capacity of that top part of our cone. So for our numbers, that's going to be 19, because that's half of 38 squared times 3.14 times our height of the cone, which is 8, divided by 3 times 0.82. So that first bit of the cone itself is 3,022.77. We're going to take 82% of that for our fill amount. It gives us 2,478 and 67 hundredths. Now let's do our cylinder, volume of the cylinder. And that is just the pi r squared times height. So 3.14 times 19 squared times our height, which was 20. And so 3.14 times 19 times 19 times 20 gives us 22,000 670.8. Now we're going to add these two together. And that gives you a total of 25,149.47 square feet. Or cubic feet, excuse me. But we really want this in terms of bushels. So we're going to multiply it times 0.8 to get it converted into bushels, which gives you 20,120 bushels. And so our total storage system, it says that we had 3 of those bins. So we're going to multiply 20,120 times 3, and you get 60,360 bushels. This is what our storage bin is actually going to hold. So how much corn did we harvest? There was 150 bushels times our 750 acres, which gives us 112,500. Now that was harvested not at dry harvest, that was with wet corn, and our corn was at must be at 15. And so we've harvested at 20% moisture. And so we need to go from 20% moisture and figure out what our shrinkage is to get it down to the 15.5%. And so when we do that, we need to figure out, okay, what is the weight of our dry corn here? And then add back in the moisture to find out what it is at that next volume. So we have the 112,500. If it's at 20% moisture, that means that it's 80% corn. And so we're going to multiply it times 80%, which gives you 90,000. And so now we're going to take that 90,000 and we're going to divide it by, that means this is 15.5% water. So that means it's 84.5% corn. So we're going to divide it by 0.845. And so when we take 90,000 divided by 0.845, we get a harvest weight for that drier corn of 106,509. So that's how much it would cost. Oh, excuse me. I just realized I was working number 17. So we're going to continue doing this for number 17. I just skipped a problem. And this is not how much will it cost you to dry your corn. This is how much will you get to start with, and I'll come back to that question. And so if you sell it at that dry moisture level, you get $5.10 per bushel. So we're going to take that number, 106,509 times 5.10, and you get $20,884.12. Let me try that again. I don't know where I got that number from. When you multiply this together, you get 543,195.90. I don't know where that other number came from. We're going to subtract from that the dryage. And so I'm going to show you how you calculate how much it's going to cost to dry it. And so we'll calculate that in just a second. So to dry your corn, you need to take how much dockage points. You need to take your total amount of corn, which is 112,500, times your 20 cents to dry per point of moisture. And so that's where it's going to get a little bit trickier. It's not just 20 cents. It's 20 cents times how far off am I? And so I take the 20 minus the 15.5, which means I'm 4.5 points away. So I need to multiply it times 4.5. And so when I do that, times 0.2 times 4.5, that gives you $101,250. So that's how much it's going to cost to dry it. So it's 20 cents per point of moisture, and the point is how many percentage points that is apart. And so when we take and we're going to subtract from this how much we actually made from it from just selling it, and subtract our additional cost of drying it to see if it's worth it for us to take the time to dry it, or should we just go ahead and sell it for the loss of those dockage points. And depending on how moist your cotton or your corn is, you may take those dockage points. It may be better a deal for you. So $441,945.90 is how much you would actually make when you account for the shrinkage and when you account for how much it would cost you to dry it. So if you, when you had that 20% moisture, and we had that 15.5% is our difference, and so that means we still have that 4.5. And so we need to figure out how 4.5 points. And if we're just going to sell it to them, they're going to take a 3.3% dockage for every point. So we're going to take that 3.3 times the 4.5 for our points. And that gives us a 14.85% discount. That means they are going to pay 85.15% of their original offer. And so we're going to take that 85.15% times the $5.10, And that gives us a $4.34 pay per pound or per bushel. Now we're going to see how much would we actually get paid if you went ahead and just harvested it there. So you had that 4.34 times your harvest, which was that 112, is we're not going to take into account drying shrinkage amount because we're just going to give it to them wet. And we multiply those together. And you get a amount of $488,250. So in this case, it would be better for me to sell it to them wet. And depending on your corn and a lot of other things, but a lot of times if you get it close to that 20%, the drying it yourself and it's giving it to them wet kind of wash out, and it will be better for you to sell it wet. So let's say your tractor broke down and is in the shop for 2.5 days. The mechanic works on it for 15.5 hours at $75 per hour, and they replace parts, and you lost $16 per hour for not having use of that tractor for that time frame. So the cost of the labor is just going to be that 15.4 hours times $75. So when you multiply that 15.4 times the 75, is going to give you 1,155. And then if you take into account the repair costs, parts plus labor, you take that 1,055 and add in your $857.46 of parts. And that gives you $2,012.46. That's not really all you have to, you're lost. Since it was in the shop for 2.5 days, you have 2.5 days of 14 hours each that you lost. So 28 plus 7 gives you 35 hours you lost times the $16 per hour. Means you've lost $560 worth of work just for having it in the shop. So we have that cost plus the 2012.46, I believe. And that gives you your total cost that you lost by having your tractor in the shop.